Hi class, in this video we're going to be talking about different data types and how they're used in Java. Java is a strongly typed programming language. That means that our variables must be declared with the data type. We have both primitive types and non-primitive types that are available to us. We'll see what that means. And of course we have these types that are available for both numeric and non-numeric data. Under our primitive data types, we have numeric data types that are integer, byte, short, long, and int. And we have numeric data types that are floating point, have decimal places, float, and double. We have non-numeric data like character data and Boolean data. Now our non-primitives offer us much more complicated combinations of data like strings, arrays, dates, other user-defined classes. Some of our primitive types are listed here with their data size, their storage requirement size. We can take a look at kind of a graphical representation of that. First of all, if I have a double variable, it is a 64-bit data storage location that's allocated for that double variable. That means that I can store a value that goes from this negative range here, this very large number, to this positive range here. So a very large number in a double. Now a float data type gives me a 32 bits worth of data, or 4 character places, and it allows me to store data in this range here, negative to positive. Scientific notation notice. Now a long data type is 64 bits, but it's a signed data type. So in that case, we're going to lose one of those 64 bits to carry that sign. So the long data type can hold a variable from this negative value to this positive value. We could put some commas in there and see how far over that goes. Bronto bytes or something, I don't know, very large number. An int data type then is a 32-bit signed data type. So we have 31 bits left over to hold data. So we can hold a number from this negative value to this positive value. So notice how I could have a number in a long variable that is too big to fit in an int variable. So that's a concern. A short data type is only 16 bits and it should have a lowercase s typo. So because it's signed, we have 15 bits available for data storage. So we can hold integers in the range negative 32,768 to positive 32,767. A byte data type is 8 bits. So we have 7 bits left for storing data. So we can store a number with the value negative 128 up to positive 127. So these data types are either integer or floating point. Saw that. Each data type has an upper limit or bound of how large of a value it can contain. Data is converted to binary for internal storage in RAM and on the flash drive and your hard drive. Now, some non-numeric data types that we might use. A Boolean variable takes 8 bits or 1 character of RAM, and a char data type takes 8 bits or 1 character. When we're using non-numeric data, our internal binary representation of this data is based on the Unicode representation of the data, or the ASCII code table. So you can see that in Canvas, that code conversion table. So whenever Java determines that we're working with a char data type, when it gives us that data from memory, it converts it using that Unicode table. If we told it was a numeric data type, it would return that data to us by converting it to a numeric data from our binary value. Java supplies an object that can store many char characters, and that's the string. So the string data type is really an object, and so it's not a primitive type. It's really an internal array of char data types. Date is another Java object that is available to us to store data. We'll see how those are used. Now, think about our data types. If we were keeping track of information about a student, we might want to keep track of that student's name, their ID, their age. What kind of data type would we use to hold that information? Well, for their name, we'd probably use a string. For their student ID, if it were an ID like here at OTC, we could use an int data type. Would that be long enough? Would we need something bigger? Could we use something smaller? For age, could we use something smaller than an int? We're always looking for the smallest data type that we could use. What if we were keeping track of information like their birthday? We'd want to use a date, GPA, maybe a float, their sex. We could use a char data type so that it could hold a code. So think about how these data types relate to the data that we want to store or keep track of in our program. So when we're working with variables, those variables have to be declared. And in Java, they have to be declared before they can be used. The declaration can include the access mode of the variable. This is going to say either public or private, and it determines whether this variable will be usable by another external class. After we specify the access mode, we have to specify the data type of the variable. Then finally, we specify the identifier or name of the variable. For example, here are some variable declarations. We declare a public integer named age. Here we declare a private variable named, that's a float, named amount due. Here we declare a long variable named amount due. Notice that we can leave the public or private access mode off of our variable declaration. What does that default to then if we leave that off? Let you decide to find that in your text. Now in these examples, we have variables that we give initial values to when they're declared. So we can also declare a variable like our public integer age and say age is equal to a value of 5. We can have a private float amount due equal to like this beginning number. We could change that anywhere in our code by specifying the line of code that says amount due equals some other value or some calculation or anything, and that would change that value of amount due. With our long amount due, we could set it equal to a value, but we might have to specify a format identifier by putting a letter L at the end of this value, this literal, to tell Java, consider this to be a long number. So what is a literal? A literal is basically any constant value that appears directly in our program. Sometimes a qualifier is required to properly use a literal value in a program, like the L, to say this is a long value. In Java, we can also use the standard arithmetic expressions, so the plus and minus, multiply, divide, modulus, or remainder. Our operator precedence works in the same way as it does for math. Parentheses come first, then multiplication, division, and remainder operations are going to be evaluated from left to right. then addition and subtraction operations are going to be evaluated from left to right. In this example, I'd like you to use the print line command to output the results of each of these expressions. We could add to the program to also print out the actual expression. Let's try it. I'm going to bring up NetBeans, and I'm going to create a new project. And I'm going to call this Exercise 2 Example. And just like before, I would like to create a main, but I don't want to put my package statement on there. So I'm going to delete out the first word and the dot of this create main class statement, and then finish. Now in my example, I want to do what it asks us to do here. So let me see if I can get that side by side. So it says let's print each of these things out. So I don't have to do too much here. I don't know if I've told you before, but if you type SOUT and press tab, that's a magic shortcut for system.out.println in NetBeans. I don't know if you're ready for that yet. We'll go ahead and let you see how that works. Now, this first statement, if I'm going to print out the value of this expression, I can't treat that thing as a string. So I have to get rid of these double quotes. So NetBeans was super helpful for me and put them in here, but I really don't want them. So I'm just going to leave it to where I just have the parentheses. And then what I want to print out is the value of this math problem. So 1 plus 2 plus 3 plus 4, and then I want to divide that by 4.0. Okay, let's see if we can run this before we do anything else. I still have my semicolon at the end. Do I have, let's see, an even number of parentheses? I can double check here in NetBeans by selecting them. That one has a match, and that one has a match. Okay, so let me run this. And it says my answer here is 2.5. Well, over here in this handy dandy slide, it says that your answer should be 2.5. Okay, let's try the next one. SOUT tab, get rid of the helpful double quotes, and I want to use the math library this time, and I'm going to use the SQRT. What do you think that is? Square root function, and I want a square root of 4. Now, chapter 4 is going to talk a lot more about using these math functions, so be sure to look at those Revel activities there. Now, let's run it. Now we should see our 2.5, and next we see 2. It gives us our square root of 4. All right, let's try this next one. I'm going to S out, and I want 1, 2, 3, 4 within those double quotes plus 99. Now, according to this slide here, Java is going to treat this whole thing as a string and just put the 99 at the end of it. It's not going to be added to that value. Let's see if that's true. Sure enough, there we go. So in order to keep from having some sort of problem in interpreting that result, Java just treated it all as a string. All right, I want to get rid of my double quotes again. This one is going to be 11 times 0.25. Now let's run. 2.75, that looks right. Okay. let's run the same thing again. This time, we want to cast the 11 is an integer, or the answer is an integer. Which is it? Let's see. Casting means I want you to take this number and convert it to this other data type. So we're going to multiply 11.025. And the theory here is, do we want to take that answer, which we saw would be 2.75, and cast that as an integer, which would cut off the decimal place? Is that what's going to happen here? I don't think so, because we just casted the 11 as an integer, and it already was an integer. So Java still converted our answer to a double or a float decimal data type. Okay, now let's fix that. If we do 11 times casting as an integer our actual float data, notice how that's a little bit different. We're saying take 0.025, cast it as an integer, and multiply it times 11. What's that going to give us? 0 times 11. Let's try it. Yep, so we end up with 0. Next, they say, I want you to cast as an int, but this time do your math within parentheses. 11 times 0.25. And what are we going to get now? To get what we're actually expecting, our 2. There we go. So now we're saying first multiply 11 times 0.025, then cast that as an integer. So we get our result. One more. This time we'll do an int on 2.71828. Is that going to give us 2 also? It should. Yup. All right. What if we use math.round? Math.round is going to round up if the number that we're using is above 0.5. So let's try that one. So what should we get there? 3? Yep, we got 3. So that looks good. What if we do, whoops, need my semicolon. Now I could do this one like their example, and our example, math.round 2.71828. Are we still going to get 3? We're rounding it up first and then converting to an integer. So we should. And then one more. We can use the integer class, and it has a parseInt method that will allow us to convert something to an integer. Now in this case, we want to convert the string 1234 to an integer. So let's see if that works for us correctly. Will we be able to tell? We can't tell too much. What if we do that? Add 99 to it. Now we can tell. It actually did the math, right? Instead of just making it a longer string. So notice how, as you work with things, you can do conversions, to parse things, to change something from a string to a number. You can cast numeric data from one data type to another. We need to be aware of truncation and possible data loss. In addition to the standard operators, Java also allows augmented assignment operators. These are where I can use like plus equal, minus equal, times equal, divide equal. So jvar plus equal 1 would up the value of jvar by 1. Jvar minus equal 10 would subtract 10 from jvar. Jvar times equal 5 would multiply the value of jvar by 5 and update that value in jvar. So we're seeing that this is just a shortcut. And we also have available increment and decrement operators. So if I use my jvar and put plus plus after it, that also ups jvar's value by 1. But since my pluses are after the variable name, that's a postfix increment. So it happens at the end of my statement's execution. Conversely, if I put the pluses before the variable name, that's a prefix increment, and it happens at the beginning of the statement execution. In these examples, it wouldn't make any difference because we don't have any other action going on in our statement. If we had other math or other things happening in this Java statement, then the order of this incrementation could be important. You'll see that as you work with it more. Now again, we can decrement in the same way, postfix and prefix. And that just adds 1 or subtracts 1. In Chapter 2, you'll see they're going to show you how to work with a scanner object. And a scanner object is just simply a Java object, some program code that knows how to read input from the system console. So we're going to use that scanner object ourselves. We're going to have to import the Java library that contains that object code for the scanner. We're going to then declare a variable as a scanner object and use the desired scanner methods to read our console data. So if we wanted to read a number, we could do next double, next int, and the videos in Rebel will show you how to do that with lots and lots of different examples. Okay, so you have a lot to do this week. I think that you're pretty well started. Your programs should be fun and exciting, and I think you'll enjoy working with your study groups. I hope that you can work everything out and that it's not too much of a stressful situation to you. So have a great week. Thanks.